Good evening, everyone, and good morning, Dr. Majumdar. On behalf of Department of Chemistry, SSN College of Engineering, I welcome you all to the three-day international webinar series organized by us. The webinar series is on advances on supramolecular and bimolecular research. Now, let me first introduce our speaker today. It is my great pleasure to introduce our first speaker of the series, Sir Shamarpan Majumder. A very good morning to you, sir. Dr. Majumdar, I know professionally and personally since 2008. Dr. Majumdar did his PhD from Bose Institute in Calcutta. After completing his PhD, he pursued his postdoctoral studies in molecular genetics at University of North Carolina, USA. He spent 11 years at UNC in various positions of increasing responsibilities. Subsequently, he made a move in biotech industry and spent 7 years where he was very successful. In 2017, he made a career move and joined LSU Health Sciences Center in New Orleans as a faculty in the Department of Genetics and Stanley Scott Cancer Center, where he was recruited to bolster university's effort in translational research in cancer and drug development. Today, he is going to talk about COVID-19, the recent pandemic. He will tell us about the origin of the virus responsible for the disease, the epidemiology, the pathophysiology of the disease, and also about the current scenario of therapeutics and the available vaccine. So without further ado, let us welcome Dr. Majumdar to deliver his talk. So Dr. Majumdar, you can start and I stop sharing my screen so that you can start sharing your screen.
Thank you, Dr. Sengupta, for your kind and nice introduction. And good evening to all of you. I know this is probably not the ideal way to give a lecture, but under these present circumstances, this is the best way possible to stay connected and exchange our scientific thoughts and ideas. So, okay, let's get down to business. As you see, my lecture is COVID-19, this once in a century pandemic, and I will discuss a little bit about the problems and perspectives as I view it, okay? I don't know whether I will cover all my aspects as Dr. Sengupta described, but let's see. So, all of you know already that COVID-19, it inflicted a widespread deaths and destruction, and also unprecedented economic fallout for this pandemic all over the world. And also it inflicted a collateral damage in terms of physical and mental health. All right. And I was looking for the global estimate just yesterday from the World Health Organization webpage, and it is the new cases, probably it even increased further. It is around, I saw just in the morning, it was 173,000 new cases, and new deaths is over 6,000. And so far the confirmed cases is more than 8.7 lakhs, and total deaths amounting to 461,000. And it is devastating, as you can see, but by no means it is over. As you can see, there is a surge in the cases in Brazil, in India, and the United States. And the United States, we were never ever able to bend the curve. And in 50% of the states in the United States, it is seeing a spike in new cases, okay? So don't, keep your eyes off the ball. Don't let your guards down. we have to do what we are supposed to do. All right, so let's see. The mortality rate now stands at 5.3%. It's huge, it's staggering by any standard, okay? And so today's learning objective, Dr. Sengupta described you. So we will understand the origin, because a lot of questions has been raised regarding the origin of the virus, whether it was actually, originated out in the wild, or there is human interference, or it's a manufactured virus. We will just present a case in both ways, in either way. We will also discuss about the epidemiology of the disease, because epidemiology, as you know, it is very important to formulate the public health strategy from the government's
Hello.
perspective.
Hello,
Yes,
sir. Can you, I'm just asking, if just stopping you for a moment.
sure.
Is he audible? Can you just type it in the chat box? Yeah. Okay. 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 Then we can continue.
So I am okay?
Yeah.
Okay.
Yeah.
All right. Thank you. So we'll discuss the epidemiology of the disease, and subsequently we will discuss the pathophysiology of the disease, means the mechanism of disease transmission, and the mechanistic view, molecular views of the disease severity. And also I will touch bases regarding the current landscapes in terms of both therapeutics and vaccines. All right. So this is SARS-CoV-2, as it is called, the virus called, and the disease is COVID-19, as all of you already know. This is weapon of mass destruction, going by the present statistics. And this SARS-CoV-2 belongs to a single-stranded RNA virus, and that is encapsulated, means its genetic material is not naked. It is covered by membrane. All right. And the previous coronavirus outbreaks, there are basically 7 coronaviruses so far known, but there are only 2 which is responsible, kind of similar to the SARS-CoV-2, and is responsible for severe disease outbreak. One is Middle East Respiratory Syndrome, MERS, way back in 2012. It wreaked havoc. And also another is SARS, the severe acute respiratory syndrome, that was also identified incidentally in southern China back in 2003. And in MERS, infected around 2,500 people and resulted in 850 deaths. So it was a staggering mortality rate, 35%. While SARS infected more than 8,000 people and resulted in nearly 800 deaths. So it is also a huge mortality rate, 10%. So fortunately, or for some reasons which is unknown to the scientific community, the MERS and SARS disappeared all of a sudden, and we still don't know the reason. So one of my friends the other day was asking me why this happened. The most plausible explanation it could be that when MERS and SARS infected people, the people were getting severe forms of infection. So they were really, really sick, and they were hospitalized very early. So they're identified, isolated, and hospitalized very early. And given this kind of mortality rate, the people who were actually dying, so remember that when a person dies, that is basically the end of chain of transmission. So chain of transmission is actually blocked. And this is basically not the intended intention of the virus. The virus' main intention is to infect and propagate and thrive in the community. So when a person dies, that is the dead end of the virus. So possibly due to the fewer and fewer infections that took place in the community, it probably died out. But in SARS-CoV-2, in COVID-19, it is fascinating in a sense. The people are not dying. The mortality rate is not 35% or 10%, and its infectivity is very high. So it is infecting so many people, and in vast swath of population, they are not getting sick. they are asymptomatic, meaning there is no symptoms, manifestations. So they are basically walking or sitting around in the plain sight. And that's why virus thrives in the community and infect from one individual to other. And that's why it is so difficult to contain. And any other mitigation strategy is very difficult, all right? So this is what I actually put you before. This is from the Nature issue in May 2020. So this is the colors are artificial, but this is the real picture. The pink tablets, the pink nodules, they are actually virus when the infected cell inside, and the cell is actually colored in green. Okay, so see, it's all over. This is the virus. So now let me come back to the question of origin. So was it originated out in the wild? So let's say it was originated out in the wild, right? And there is one coronavirus in the bats. There have been 90, somewhere between 90 to 95% sequence similarity. So people were basically jumping into conclusion that it was originated in the bats. So basically what they were saying, it is zoonotic spillover or transfer. That is a species crossover. Okay. Now bats are, as you know, is a nocturnal, and there is not much known mixing between humans and bats. So who is to be blamed? Well, this is our collective human behavior that are responsible, even if it is originated from the bats, because bats are not getting into your bedroom through your window. They are in the roost, they are in their nest. They actually come out of their roost twice in the day, once for the food, and they go back to their roost. So how come, if it is not the human behavior, bats could be held responsible for this zoonotic spillover? So this is our greed, our profiteering. We are actually, deforesting a land area equal to the mass of Netherlands every year. We are actually burning our Amazon down, that produces 20% of the world's oxygen. We are squeezing the natural habitat. We are actually hunting them down. We are caging them into the Wuhan, China, exotic meat market. It is our overindulgence in the animal meats, even the exotic meat. It is what is called the gluttony. And it's one of the 6 sins described in the Bible also, that is responsible for this. So we have to be held accountable for our behavior, And the bats, though they are known to harbor coronaviruses, but somehow they are not known to manifest any disease symptoms. So they have developed a mechanism where they could be able to contain and have a peaceful coexistence with the coronavirus. But think of a situation. If you are actually hunting them down, if you are caging them in, then you are inducing a stress in the bats. And when under the stress condition, you never know, probably, the same coronaviruses which were kind of contained and mitigated in the bats, they actually showing symptoms, because it probably breaks their resistance mechanism, and now the virus is actually shedding. And now the humans may have close contact with the bats in the Wuhan market. They got actually contracted and transmit the disease. This is very, very possible. And also you have to realize in the last 30 years or so, the human behaviors change. In these days it is very possible that today I am actually visiting a African safari, and tomorrow evening I can walk into a crowded pub in the London supermarket. So if anyway, by chance, I got contaminated or got a transmission in the Kenya, I can very well transmit other people in the pub. So it is the very human nature that has to be responsible for this zoonotic spillover. And see, the study of the bats could also provide important clue to developing therapeutics. What is going on in their defense? What is their immunity status? How it is actually contained the virus infection, so it is not manifesting in there. So this is the natural origin. So basically what I am actually harping on, it is the human behavior, their profiteering, their greed, their gluttony, all of this is responsible for this zoonotic spillover. All right. So, and they are actually giving us a start warning, because they are telling, hey, you probably think that you are the master of the universe, but you are not. So Any other species, any other animals other than these humans, they are absolutely fine. They are happier more than ever because they are coming into the close contact, they are visiting the tourist places, they are also maintaining social distancing, they are visiting the tourist places. You can see Himalaya in terms of environmental pollution, it decreased so much in the last 30 years. You have never seen Himalayan, just going over the rooftop in a Jalandhar. So this is all happening, and they are telling once this disease is over, once this epidemic is all done and dusted, don't think you are the master of the universe. Just think you are one of the species, and we should live all in a good environment. All right. Now let's actually sit back and step back and let's see whether it is a manufactured virus. Now, natural virus, the origin of the natural virus theory is still the popular theory. It is actually pushed forward by the establishment scientists and the government sectors. But let's say, so in order to debunk the theory of natural origin, you need to come out with proofs. You need to come out with evidence. It is just like in statistics. You have to, if you want to reject a null hypothesis, you have to come out with some statistical significance to show that null hypothesis is wrong, this alternative theory is correct. So like that, let's recap the SARS-CoV-2 spike protein. This is the master manipulator. So SARS-CoV-2 protein, they contain spike protein, okay? You all know by this time. The corona is actually the spike. In Latin, corona means spike, all right. So in the spike protein, if you zoom in a little bit, you can see the spike protein contains two subunits. It is S1 subunit. The S1 subunit basically attaches to human ACE2 receptor. ACE2 is angiotensin converting enzyme. It is abundant in all the cells, particularly in the epithelial cells, in the lung cells, in the endothelial cells. And the S1, once it binds to the ACE2 receptor, it actually snaps back, it releases, and the S2 unit, subunit, subsequently, after another cut with serine proteases, transmembrane serine proteases, it is getting internalized into the host cell membrane. Okay, this is what the virus actually follows. It's a very perfect, very sharp, and it actually binds to ACE2 receptor with remarkable efficacy. All right. So let's say, and remember, there are two cuts. It is concomitant cut. One is the furin cleavage site. I am coming to the importance of furin cleavage site. The furin cleavage occurs in the S1-S2 junction, followed by another cleavage with the serine proteases, and it gets internalized. Okay. Now, what is the importance of furin cleavage site? Let's see. So this furin cleavage site is fascinating. It's fascinating because in other bad coronaviruses, this is the SARS-CoV-2, the present COVID-19 virus, and this is the other SARS-CoV virus in the bats. So never before this kind of perfect furin cleavage site exists in the other coronaviruses in the bats. So if bats are supposed to be the original host, it is very unlikely that this kind of a tailor-made furin cleavage site is getting incorporated. It is getting the recombination or insertion, whatever, this kind of one after another happened out in the wild. It is almost unlikely, okay? So this furin cleavage site is one, it actually gives the virus an added advantage to bind to the ACE2 receptor with remarkable alacrity. And not only this, what it actually does, that's why this alternative hypothesis is gaining a lot of traction in the last 1 month due to a series of very high profile papers. In another paper, they have shown that this ACE2 receptor, when it binds to this furin cleavage site, the furin cleavage site, what happens, the receptor binding domain that actually resides on the furin, on this S1 subunit, it can form a lying down version. So the form it is presenting is lying down, and it is used for immune evasion by the host cell, or in other words, it actually binds stealthily to the ACE2 receptor, and there is no red flag the human cells detect to actually take down this invading pathogen. But in other SARS-CoV viruses in the bats, the frequency of standing up the RBD domain was very high, so it actually presents a red flag, and the host immune system could actually provoke a strong immune response. But in the SARS-CoV-2, It does not. It actually imparts the RBD binding site a remarkable advantage that it can attack the H2 by even the line down formation. So just before it is attaching, it just stands up, binds to the H2, released, and subsequently the serine proteases cleave the H2 and then virus entry into the membrane. Okay? So this is what is actually a very remarkable, and it was not present in the bats. Not only this, in the next slide I am going to show you, this is another paper in the last 1 month or so, 1.5 months or so, that what they are finding with in silico comparison of spike 2 and H2 binding affinities across species, what they have found, just look at this. It is beyond the scope of this, discussion, because it will take a whole lot of time, but just look at the binding energy. So higher the binding energy with the H2 receptor and the SARS-CoV-2 spike protein, the higher is the affinity for the same receptor. So what they have found, it is remarkable that the H2 receptor binding with the SARS-CoV-2 spike protein is highest in case of human H2. And look at this bat, it is way lower in the table. Okay, so any kind of bat H2 receptor, this virus originated bat, is kind of unlikely, because this was evolved and selected for the human H2 receptor for binding and subsequent infection. It is so much primed for human H2 receptor, and it is very unlikely that happened, so these two theories, this series of papers, high profile papers, actually gives rise to a fundamentally that whether is it something that there was human intervention, is it something the virus was manufactured. And there is a likely scenario, because I'm sure you know by this time that there is a biosafety level 4 laboratory, and which is known to do a lot of bat research there in the Wuhan, China, and it is situated 300 meters away from the Wuhan, exotic seafood market. So it could be a possibility the people or one of the scientists who was actually doing research, this is gain of function research, who was doing research, might have actually infected, might have got the infection from there, and he or she was asymptomatic, so did not showing any symptoms. He or she came out, going into the Wuhan seafood market, it would very well happen and infect a whole lot of individuals, and it's a boom thereafter, basically. But now your question would be that why don't the establishment scientists or the scientific community, they are not telling? The reason is because the gain of function research, if it is proved, if it is they're telling that yes, it was manufactured virus, then it will face this gain of function research, the virus research will face a tremendous backlash, and they will be defunded. And also that's why the reason probably they are not telling that it was manufactured. And also there will be a backlash against the Chinese people living all over the world, particularly in the United States. There's a lot of Chinese, they're in high position, That's also some of the political fallouts that might happen if the mainstream scientific community is telling that it was manufactured. But again, hey, I am not telling that it cannot happen out in the wild, but this kind of, perfect tailor-made furin cleavage site and all these things, it actually, poses a big question mark. The origin of the virus happened out in the wild. All right. So another stuff I want to tell you in this respect is the mutation and the natural selection. So you have seen in the North America it is ravaging in the last 3-4 months, and now a new study from Scripps Clinic, I think it is a very, very recognized and famed research institute, as you know, most of you know, in the United States. So they have identified a point mutation, and that leads to a single amino acid change from aspartic acid to glycine. And so it is in the 604 region of the viral sequence. It is D changed to G, so aspartic acid changed to glycine. And this mutation in the spike protein make it much more stabilized. And then this stable form of this spike protein is, they are telling, it is actually causing the explosive spread of the virus of COVID-19 from the mid-January. Okay, and what is this called, this viral epidemics and everything is basically a matter of maths and probabilities. And whenever a better survival mutant actually selects in, the natural selection comes in, because this is a universal mechanism that is functional both in all living beings, be it bacteria. So we are always scared about the emergence of a antibiotic resistance bacteria due to a mutation. That's why we're so, or in the cancer cell, even a mutation develops, the natural selection selects it because it is the survival of the fittest, and then it is becoming treatment resistant. So this mutation is always a great worry. However, I would say that this SARS-CoV-2 virus is not prone to mutation that much, so there is hope for those vaccine, at least at this time being. But this is a mutation that should be regarded, and also that's why why this mutation is important. That's why you don't want them to transmit and transmit different individuals, because the more you are letting the virus to transmit and transmit and propagate, the more is the chance, more is the probability it is going to end up into another mutation. It's a matter of probability. And then natural selection comes into play and it will select a mutation with the better survival benefit, and that will be deadly. All right. Then this is just a paper I just want to mention. Now the mask is important. It is actually proven by scientific evidence. It came out in Nature, just in PNS in June 11. The mask is the most effective protection. Wear them the end, and social distancing alone is not enough. The combination definitely works better, but mask is the number one. It is a deciding factor. Okay, and if you are not wearing mask, here is a tale of walking contradiction. These two pictures from the United States. It is from our city, New Orleans, just day before yesterday. I can hardly see people wearing any mask here. This is in the United States, and see how the Vietnam, with the limited resources, they actually, they jumped into action early January. They were swift, decisive, and proactive. They took no chances. They had 0 deaths and very few active cases, despite their sharing a long border with China. Same is true of New Zealand. They were proactive, and they were paying hits. The people were paying hits to what their leaders demanded, and it actually, resulted in 0 new cases. Probably it again spiked up 1-2 cases, but again it is negligible compared to what we are experiencing in the United States. No mass group, and it is a disaster. Okay. So now let me talk about some epidemiology and herd immunity. So those of you who have actually watched the movie Contagion, I believe it is in 2011, must be familiar with the term R naught. So R naught is a very, very popular term for the epidemiologist to formulate their public health strategy, because it gives you a number, it gives you the basic reproduction number. So basically how many people one infected individual can actually transmit. Basically that's what gives you a value. It actually gives you a proper number to come out with the vaccination trial. It actually gives you a number that how many people or what percentage population should be vaccinated, in order to protect the other weaker section who might have any hypersensitive reaction if you are actually giving any immune vaccine jabs or something. So basically the herd immunity, it was originally came from the livestock in a herd, and the protection of the herd as a whole, which is brought about the presence of immune individuals. That's how the whole concept of the herd immunity came into play. The number of individuals in a population who are immune to infection with an infection agent may depend on the proportion who have previously been infected with the agent and the proportion who have been vaccinated with the efficacious vaccine. So basically you can gain the herd immunity by 2 ways. Okay, one by vaccination. This is the most effective way. This is the most sought after way. And other is you let it go. And sometimes people are saying Sweden is following that model. Then you let it go, just don't care. Once a community, 70-80% of the community is getting infected, it will automatically protect. The virus will lose its infectivity because there is not enough people to infect. So the other 20, 25, or 30% weaker sections who are not infected, it will be the termination of the chain. So, and then the others will get protected. But the problem is, as I showed you before, that this concept of mutation, the more you actually give the virus the opportunity to infect people, then more is the chance to come out with a gain of function mutation, which is a better survival frequency and maybe much more infection. So I don't really go by the way of herd immunity by letting the virus infect people and then impart immunity to the other 30%. Vaccination is still the best effort to go. Okay, and look at this number, the Arjuna number, and the transmission. So basically it denotes, again, as I told you, the number of individuals that one infected individuals can infect or transmit the virus. So if you look at the measles, so it was anywhere between 12 to 18. Of course, it is very difficult to give you a discernible number because the R0 varies depending upon the density of the population, etc., etc. Because the R0 number, I'm sure, will be different in Alaska and New York. You understand, and rightfully so. So look at the measles, the R0 number, and some other, highly infected outbreak of chickenpox, 10 to 12. So this is our COVID-19, airborne droplet. It is anywhere. Now, this is not the end. So it is kind of estimated anywhere between 1.4 to 3.9, depending on the population size, depending upon the demography. So let's say it is 3. It is way below measles and chickenpox, but is much higher than influenza and other kinds of, in the lower in the table. So let's say they are telling, in order to impart the herd immunity, so let's say vaccination effort. For the diphtheria, measles, for measles, you need around 95% herd immunity threshold in order to protect the 5% because they were so infectious. As you see, it was 12 to 18. In mumps, which is 4 to 7, let's say roughly 5, it is around 80%, say. So with 3, let's say the R0 is 3 in COVID-19, so it is easy to formulate, easy to envision a case that you need around 70-75% of the population to be vaccinated in order to protect the other 25 to 30% of the population. Okay? Now, the question is, do you want to go and actually get the herd immunity by letting the virus to wreak havoc in your population? Because already the death is staggering. In the United States alone, if you go by the herd immunity, just letting the virus go and infect the population, we are actually thinking about close to 1 million deaths. Okay, that is staggering. So I would not go that far. All right. So let's discuss about the pathophysiology of the disease. So I have time, right? Let's see the time and everything. All right. So let's discuss the pathophysiology of the disease. So what makes COVID-19 so different and difficult to deal with? So now, just to give you a very bird's eye view of the immunity, again, it is the fastest growing branch of medicine. I mean, it actually revolutionized the treatment in the cancer, immunotherapy and everything. So I cannot tell you in a couple of minutes, but having said that, the two arms of the immune system is the innate immunity and the adaptive immunity. So once a person is getting infected by an invading pathogen, the innate immunity gets activated in the very early after the infection. In a couple of hours to 2-3 days, this is basically the generic. So it is a generic nature of the innate immunity. All the cytokines, chemokines, it is getting activated and is trying to take down the invading pathogen. But in the meantime, due to the interaction with the T cell and B cells and the adaptive immunity arm, the B cells also start producing antibodies, and the T cells, due to the cytotoxic activity, they are taking down the invading pathogen. So this adaptive immunity is very specific. And one of the major hallmark, the difference between adaptive and innate immunity is the generation of the memory T cells. The main approach, the whole approach, the central hypothesis of vaccine is to generate and boost up your adaptive immunity so that it can produce a lot of antibodies, not only antibodies, the neutralizing antibodies to take on the virus and neutralize it, and also can perpetuate the production of memory T cell so that in the future, if you are infected by the same pathogen, you can immediately recognize and then attack that invading pathogen. So this is the two fundamental arms of the immunity. Okay. So if we see, it is, I forgot to mention, this is from I think it's from New England Journal of Medicine paper. So I took it. So it came just 15 days back. It's a radiology report from recovered, this ABC are recovered patients, and these are the deceased individual from COVID-19. So, the one of the recurrent features pattern of the severity of the COVID-19 patients in the radiology report, you see a broken glass opacity. You see this is called the broken glass opacity all around. This is due to the edema, this is due to the fluid retention and the lung alveolar. So you will see the broken glass opacity. Here it is noticed, but they recovered these ABC patients. In the DNA, just look at this broken glass opacities all the way here, and it is extensive damage it writes. So this is the radiology report. So this is actually a serious issue. And look at the lung histology report from the deceased COVID patients. So a lot of things are happening in the histology, in the lung histology, in the COVID-19 patients, in terms of coagulation and blood clotting disorders. We have seen patients, I am not a physician, but I have heard that the patients are actually dying. Patients are dying due to blood clots everywhere. It is pulmonary embolism, it is clot in the lungs, they are getting stroke, they are getting clotting in the lower limbs and all over. This is a very discernible and this is a very consistent pattern. So why this is happening, still nobody understands the mechanism. But you can see the microthrombi. This is the blood clots. It is happening in the septa of the lung patient who died from COVID-19. You see the blood clotting. And this is the scanning electron micrographs from healthy lung, and see the extensive damage these COVID-19 disease patients were created. There's a loss of architecture, there is a loss of the spine, membranous structure and everything. And if you look at this, so there is also a case of silent hypoxia. What COVID-19 patients are facing, it's called the happy hypoxia or the silent hypoxia. What is hypoxia? It is the lack of oxygen. The same thing what you experience when you go into a higher altitude or in the mountains. The COVID-19 patients are also experiencing the same thing, but initial stages, even when there is a drop of oxygen level from say 99 to 90, it is severe in other kind of illness. But here, the patient unconsciously, they are actually compensating the effect. They are probably breathing desperately, so they don't realize, and also the cells, they are actually finding new ways to compensate. It is called the new way of angiogenesis, intersusceptible angiogenesis. Sorry. Yes. So it is angiogenesis is happening, and it is all over for the patients. And in the D also, you can see the arrowheads and everything, also structural features of the endothelial cell, which is the endothelial cells with the lining the blood vessels. Its also architecture is actually damaged, and you can see how, if you zoom in, how the architecture looks like. But nobody knows actually what is going on, why this is so much of hypoxia, why it is so much of this blood clotting disorder. Having said that, I must say 80% of the patients, they don't show any kind of severe disease. So 50% is asymptomatic, 30% is mild, and around 15 to 20% they are showing severity of the disease, and out of this 15-20%, around 10% they need 7 to 10% they need ventilation. Okay, and there is a probable link. We think, well, it is not yet proven, but there is a paper, and I'm glad to say that Dr. Sengupta actually worked with the proteinase back in 2000, I believe 2010 to 12. So now it is more than ever it is important. There is a probable link between hypoxia and blood clotting, and there is a paper that came out in the very high impact journal, Nature Reviews Immunology. They are also telling proteinase could be a link, because the proteinase, what it does, probably you all know by this time, the famous cytokine storm, when due to the SARS-CoV infection, the monocytes are getting attracted, and they actually induces the cytokine storm. Cytokine storms are nothing, but basically it is because the body is always under the balance between pro-inflammatory cytokines and anti-inflammatory cytokines. For the pro-inflammatory cytokines, IL-6, IL-2, IL-1B, TNF, that is tumor necrosis factor alpha, these are the most important, and for the anti-inflammatory cytokines. So when the pro-inflammatory cytokines wins over the anti-inflammatory cytokines, just to tell you in a roughly, then the body is getting severely, under the influence of the cytokine storm. And one of the major player that actually contributes to the cytokine storm, at least in the COVID-19 patients, it is interleukin 6. And by the way, just 4 days back, 3 days back or 4 days back, there was a major paper in New England Journal of Medicine that actually analyzes the genome-wide association studies in the COVID-19 patients who were severely infected compared to mild infection. And they actually deciphered, they actually traced, there are 6 genes clusters which is in the chromosome number 3 that may be responsible for the severity of the disease, and one of the genes responsible in this cluster of genes in interleukin 6, and other genes are also blood groups. So they're generally saying that blood groups with A, they have a 50% greater chance of getting the severity of COVID-19 infection, and the blood group with O, they have similarly 50% less chance of getting severity of the disease. Okay, so this is a major paper, just came 4 days back. So interleukin 6 they also found in the gene cluster of severe COVID-19 patients, and it is actually a major player. And what they are saying, that is monocyte and interleukin 6, they also actually activate tissue factor in the endothelial cell. This is the major cells in the blood vessel. The tissue factor in turn activates a series of blood clotting factors and activate thrombin. And thrombin is responsible for the blood formation. And in a lot of patients, particularly in Italy it happened, there is a lot of production of D dimer. This is one of the hallmarks. When there is too much of the blood clotting going on, the resultant fragmentation of that blood clot resulted in D dimers. So if you measure the D dimer levels, it is very high. That means the patient is having a proactive blood clotting going on there. So they have to be monitored very carefully. Okay, this is the blood clot, and the blood clot, more the blood clot, you are associated with more hypoxia. So what it does, the hypoxia, there is a paper in the blood back in 2018, they showed that hypoxia blocks proteinase production. Now proteinase is an anticoagulant, so that makes a lot of sense. So the coagulant activity, when the anticoagulant level is decreasing, so it actually increases the coagulation activity. And also interleukin 6 also, it has been known that it blocks proteinase. So if you block proteinase, then probably it is giving the system a more prevalence of these clotting activities to go on. So one of the mechanism, they are actually telling, one of the mechanism could be supplementing proteinase, because the anti-heparin therapy and the therapy is actually they are giving for the COVID patients. All right, this is just a anecdotal still. There is nothing established in the COVID-19 patient that proteinase is deficient, but this is probably a possible link. All right. And now the demographics with the high mortality. Let me tell you that of course, the aged people over 65 years and people with underlying health conditions, they are actually getting affected, much more than the healthy young individuals. Percentage of males are hospitalized little more than the women's. The hospitalization rate for males is 16, ICU 3%, died 6%, compared to females a tad lower here. And the underlying conditions in the US statistics, again, this is not a global statistic, in the US statistics, the underlying conditions for the cardiovascular disease, this is 32%, followed by diabetes 30%, and the respiratory disease 18%. And also in the USA, there is a those who are underprivileged, those who are, there is a large social disparity, going on. And the Hispanics, which actually constitute for only 17% of the population, the 32% of the Hispanics, they actually died. For the African American community, who constitute the 13% of the population, their death rate is among the highest, 22% in the USA. And also the same thing is happening. The indigenous people in Brazil, they are dying at an alarming rate. Or also you have seen the underprivileged, the underprivileged class, they are also dying in India too. So this COVID-19 and also laid bare the festering sore of health disparity and social disparity that contribute to this disproportionate mortality rate, and this big debate going on. All right. And so let me just touch bases with this mechanism of action. It's complicated. However, let me tell you, this is a blanket disclaimer. There is no, at least in the USA, there is no FDA approved, Federal Drug Administration approved drug that is universally accepted for the COVID-19 patients. We have seen remdesivir, we have seen convalescent therapy, we have seen here and there, dexamethasone in UK, they are approved, but these are not for the emergency use. So here at the mechanism of action, so what I told you, they actually get entry by serine proteases and the H2 receptor and the furin. So anything that could block, and it has shown in vitro studies that if you block the serine proteases by the inhibitor or H2 by H2 inhibitor, you can block the cell entry. And this is endocytosis. So there was a lot of debate and everything going on with the chloroquine, hydroxychloroquine, and everything. This is a high-profile study. But the chloroquine, hydroxychloroquine, they actually increase the alkaline content of the endosome. So it can block endocytosis theoretically. But for the adverse effect, that is completely different. Now, once it gets entry, then this SARS-CoV-2 also carry their own RNA-dependent RNA polymerase. Okay? RNA-dependent RNA polymerase, RD, RP. So anything that blocks RNA-dependent RNA polymerase, just for the replication, you can actually block the transmission of the virus. You can block, they are actually busting up. And remdesivir, which is in the United States approved for the severe COVID-19 patient, it actually reduced the rate of hospitalization from 15 days to 11 days. It might not be, sounds huge, but again, you understand when the patient is under ventilation, there is a lot of, economic burden, cost, so even 4 days of decrease is a huge thing. So remdesivir, and also I have seen the Glenmark, they have also come out with in India, they have also come out with just this RNA-dependent RNA polymerase blocker. So that's where it is also. And any kind of blockade of replication, it will work. So interferon therapy, they are also, and also in UK they have found dexamethasone, a steroid, that is the immunosuppressive drug. It also works in the severe COVID-19 patient. It makes a lot of sense. As I told you, the cytokine storm, if you can block the cytokine storm, the patient will get the benefit. But I would not actually say that recommending or giving what is this called, the anti-immunosuppressive drug early will be beneficial, because you will also lose the benefit of the anti-inflammatory cytokine that is also comes into play early. You are also blocking them blanket. So blanket blockage of immunity in the very early in the COVID infection, it is not recommended. But in the later, when the pro-inflammatory cytokines, it is all over, it is taking over the body, it makes a lot of sense. Now regarding the COVID-19 vaccines, I must tell you, the vaccine trials is going on, it is good. We have already know many things, most of the things. There is Oxford vaccine, and there are almost in this vaccine line, there are almost 5 vaccine trials that is going on in China. The Oxford vaccine trial, it is in collaboration with AstraZeneca in the UK. The modern RNA, it is the United States. There is also Pfizer along with the BioNTech that is in the Germany going on. There is Sinovac in China. There is Wuhan Institute of Biological Products, and there are a lot of stuff. So let me highlight the Oxford and modern RNA that are using different platforms. Oxford and CanSino, they are both using the adenovirus vector. Why they are using adenovirus vector? They are actually putting the spike protein genomic DNA loaded into the adenovirus, vector. So adenovirus vector, it is actually 30 years of study. It is known to provoke a severe immune response, and that's why it might actually provoke a severe immune response in the humans also. And in the phase 1 clinical trial, let me tell you, there is a lot of clinical trial phases. As you know, phase 1, phase 2, phase 3. In the phase 1 clinical trial, it is given, the jabs is given only between 18 to 55 year individuals, not more than that. In the phase 2, there is more people. There are 400, 600, 800 people. The phase 1 is basically explicitly to test the safety of the dose. And in the Oxford and the modern RNA is using a different platform. The modern RNA and the Pfizer, they are actually using the viral messenger RNA. So the thing is that, so when you actually inject in the muscle injections, the messenger RNA, it is actually getting there, and it is inducing the messenger RNA protein or the spike protein. But since the spike protein is not enough to produce the whole virus, because it lacks the other components, it is not going to produce a a infectious virus. But having said that, the body tricks the body to recognize the spike protein as the whole virus and can mount an immune response. So that is the whole vaccine theory is. So in the phase 2 trial, they are actually putting it into 600 individuals, and both Oxford and Moderna, they are stating that everything is going fine, and they are expected to start the huge phase 3 trials from the July. The Moderna will test in 30,000 individuals, 15,000 will getting a jabs of placebo, and the 15,000 will get the jabs of the original RNA. And you might think that the result and the sufficient to test the efficacy, you need to have a pandemic in place. If the pandemic is gone, it will not effectively come out with any result, because the whole idea is the placebo control group who are receiving and the jabs which contains the real vaccine, they will also go back to the work, they will resume the normal activities, and in the 2 months or 3 months, if the placebo control group are getting infected at a much higher rate than the arms which actually received the main vaccine, then it proves the efficacy study. But the vaccine is only drips and drabs, then possibly it will be take months and months and months. That's why Oxford and probably the CanSino, I heard, they will actually resume their phase 3 trial in Brazil, where it is actually kind of picking up. So that makes a lot of sense. And the Moderna vaccine, I already discussed. In a release, the biotechnology company explained that the study will evaluate the safety and efficacy of the vaccine in 28 days apart. And in the mouse, they have produced sufficient evidence that it is provoking a strong neutralizing antibody. So it is very different from just producing antibody. All the antibodies, they might bind to the virus, but not silent to fend off the attack of the virus. You need to have the neutralizing antibody. It is just like, say, the antibodies are binding the virus in the different sites, but not the business end. The business isn't here. So until unless the neutralizing antibody is binding to the business end and effectively neutralize the threat, it is no good. But this Moderna vaccine or the Oxford vaccine, they are actually producing sufficient neutralizing antibody. So there is much hope and optimism here. And I am not actually going into that. Already it is 45 minutes. This is a black light experiment. This is showing how infectious the virus is. And of course, thank you very much for listening to my talk, and thank you organizers for running this wonderful event. Thank you. So let me just stop sharing, and I am open to questions. Hello.
Hello. Yeah. Thank you
Yes.
Thank you for very nice and informative talk. So here are a couple of questions that we are getting. Bhushan Patel asked, "Are COVID-19 can infect our pets?" Yeah.
Yes. I have just said in the newspaper. It is not in the scientific, but I have seen the cats. One of the cats was getting infected, so probably yes, I would say. But I have not seen any, high profile, high impact paper in that, so I cannot actually comment further.
Okay, I have a question for you. So, so you have shown that for this hypoxia, you have actually showed that because of blood clot, right? Hypoxia can happen. Is there any other thing other than blood clotting which can trigger hypoxia? Because that's very important, because people are often getting breathlessness.
Yes. Yes, so anything, so hypoxia is basically the mechanistically hypoxia. There is a HIP1, even hypoxia inducible factor alpha. So whenever the HIP1 is getting stabilized, so they are actually basically a sensor for oxygen, low oxygen. So whenever there is a low oxygen, the HIP1 is getting stabilized. So when under normal oxygen condition, there is HIP1 is not stabilized, it is degraded. So anything that induces hypoxia, induces HIP1 alpha, it can actually induce hypoxia. So there is a lot of stuff that can actually induce hypoxia, but one of the thing is hypoxia. But there is, VEGF, vascular endothelial growth factor. In the cancer, hypoxia is a very, very important factor. In the pancreatic cancer, for example, it is actually, it is one of the most aggressive cancers, the pancreatic cancer. The death rate is 80% of the patients die within the first 6 to 12 months. Hypoxia is very high in the pancreatic cancer patients. And one of the reasons the hypoxia is high, there is a lot of blood clotting. The hypercoagulability, it is also high. So now proteinase is also lower in pancreatic cancer patients. So it is important to find out what's going on in pancreatic cancer. So there are many other factors. One of the factors that is coming to the top of my mind is vascular endothelial growth factor, and also NOTCH signaling is also important for hypoxia and angiogenesis.
Okay, we see another few questions with somebody asked, K. Gajanan, can vaccine developed in next 3 to 5 months? It will be very difficult to answer.
I think no, I'm optimistic here because now we have a very ramp up production, and let me tell you one thing. So the private public partnership, that what we have witnessed in the COVID-19, it is unprecedented. There is a kind of silos in the public private partnership, but they actually cross this boundary. So there is unprecedented government funding going on, and this is ramping up the production. They're investing a lot. So basically they're minimizing the time. So they're investing in the resources, the centers beforehand, before the phase 1 trial is over. So they're telling it's no matter what, money is not important, life is important. So in this way, they're ramping up the production, they're investing a lot of money. So probably yes, but however, it is unfortunate, but I'm telling you, so we need to have the pandemic somehow. It is like Brazil or something. Some of the areas pandemic should be there in order to have a firm answer whether the vaccine is successful. Otherwise, you have to go in the other way. You have to have volunteers who will be ready to take the virus load, in order to see whether the vaccination works for them. So that is a very, very hard way to answer the question. But yes, I am hopeful. Yes.
Okay, and then the next question comes from Chellam from IIT. She is asking, considering the origin of the virus and assuming it is engineered, does the current COV-2 affect bats? And if that's so, then how do bats respond to the virus?
Okay, can you repeat once more?
Yeah, it is like considering the origin of the virus has to be engineered.
Mm-hmm.
But if it is engineered, that engineered virus, can it affect COV-2? Can it affect bats?
I don't know unless you do it, because you have seen the virus generally, they can actually fend off the manifestation of the disease and the ordinary condition. But again, even if it is infection is different thing. Suppose we are actually walking around with hundreds of pathogens every time, but we are not getting any disease. We are not actually going into bed. So if you are fending up nicely, if your immunity is okay, if you are fending the pathogen, it is all good. But you never know under the stress condition. Again, if you are telling, you are actually caging in the virus, just like the pangolin also. The pangolins, in my free energy slide, I have shown the pangolins were the second in the H2 receptor of the pangolins, with the SARS-CoV-2 the second in line. So it could be what is called convergent evolution. So convergent evolution means the pangolins could be infected. So that is important. Pangolins is a potential, you have to monitor it carefully, and you have to enforce the strictest law to enforce a ban on the pangolin trade and trafficking. That is always there. But I cannot tell you until and unless, being a scientist, until and unless you do the experiment.
S. Priya asked, in last century, with less developed technology and medicine, they controlled infectious disease like cholera and TB. But why it is difficult to control now at present with so much advanced
because as I told you, this virus is new, okay? Because the genetics, because this is a new virus, whether it is engineered or it was originated out in the wild, it is a new virus, it is a new genomic material. So in January only, we came to know the genomic sequence from the China and another institute, Australia. They actually produced, put that into the website, and then the scientists tried, because you understand, there is a lot of time lag, because in order to come out with a potential therapeutics or vaccine, it takes 10 to 12 years with an investment of $1.4 billion. So it's not easy. You have to go through the sequential barrier. You need to do the preclinical studies and then clinical studies. There is a protocol you need to follow. But here we are breaking all the protocols and everything just to accelerate and ramping up the production and coming out with the vaccine. We are so desperate now. but takes time. It's a new virus. It's a new virus. It's a new virus with a new genetic genomic sequence, which was unknown to the human. Okay, so that's why it is. But with the unprecedented measure going on, I am optimistic. I mean, with the vaccine, at least in the 3 to 5 months of time. But I don't know whether all the people will receive it, because ramping up the production, out of the 7 billion people, probably you need 1 billion doses in the first 3 months. I mean, that's an uphill task. So let's see. We are hopeful, but hope and hype is not enough. And for science, we need data and evidence. All right.
And second, one more thing is that you have shown in some slide there are some R0 values, right?
Right. Right.
So that R0, is it using the information from symptomatic patients only, or does it include asymptomatic also?
Okay, that's a good question. So it is called R naught. This is not R zero. Basically, technically, it is called R naught. So R naught value is epidemiologist. So now, the asymptomatic patients, how it goes into there, because those values in some of the patients, chickenpox, measles, that dated back there, I don't think at that time you have those kind of sophisticated PCR machines, and the asymptomatic patients, they were actually tracing and everything. But the asymptomatic patients, I don't think, if they don't feel the urge to go and appear and being tested, those values that you actually see, it includes those asymptomatic patients. But if they were tested, it is a fair game. But I don't think many of us who are asymptomatic, we would go by ourselves and actually, take the test. Unless we know that some of my relative or friends I mixed with, they were tested positive, then we will go, even though you're asymptomatic. But otherwise, I doubt that all of those data, they took all those asymptomatic information when actually present those are not value.
Okay, that was asked by Chellam again. So if there no more question now, then once again I thank wholeheartedly to Dr. Majumdar and all the participants who present today with us for this talk. Uh, then we we end our session now. I'm telling all the participants, you will get your feedback link and the registration link at the end of the series, 3-day series. So we'll send everything, all the feedback link and everything at the end of the 3 days talk. Okay, that's all from us today.
And
Thank you.
thank you, Dr. Sengupta, and thank you all. Stay safe and have a good night. Thank you.
Yeah. Okay, so we end the meeting. See you all tomorrow at 6 o'clock in the
Thank you.
evening.